Welcome students. Today let us look at the convolution layer of the overall CNN for pattern recognition applications. So what is the purpose of convolution operation? As we have already saw, it is mainly used for extracting the features of the input data. So how can we do that? Let us take an example. So here is what a human being can see. They can see their dogs in a garden. But when you look at your computers or algorithm, they are going to look at only the numbers behind the pixels of these images. So we are also going to play with numbers and determine the convolution output. So how do we do that? Let us assume this image is of size 32 cross 32 cross 3, where 32 corresponds to the row wise pixels and 32 corresponds to the column wise pixels and 3 corresponds to the RGB image. Say for example, if you are using a gray level image, it is also fine. Then you will not have the third element. Now, assume that you are left in a dark room. How will you search for an object? Normally, you will take the support of a torchlight or a flashlight and then try to search in the room. Now, this situation can be compared with the machine trying to find an object in the image. The overall room is nothing but your original image F. And we already saw in the previous video that we need a duplicate image. That image is nothing but your flashlight. Technically speaking, we call it as a filter or a kernel. So when you overlap your torchlight or a flashlight on the room, you will be able to get some small portion of the room as output. You assume you will have a torchlight of size 5 cross 5 pixels, which is very much smaller than the bigger room or the original image. Now, when you superimpose your kernel or filter at one corner of the specific input image, you will get that portion. That one portion can be treated as a sub-image. So now what happens? When you move your torchlight, you will be able to find the different portions of the room as output. Now again, the size of the torchlight also does matter. Say for example, if you are searching for a needle in the room, then the dimensions of the torchlight should be big enough. Or if you are looking for a bigger object, then the dimension can be relatively less. Still, you will be able to find out. The same concept is applicable here too. The success of the pattern recognition is based on the dimension of the filter and also the content or the intensity of the filter. A filter is also an array of numbers with size 5 cross 5 cross 3. Say for example, if it is a color image. Now you are ready to do the convolution operation. Let us see how we are going to do that. Each filter parameter is multiplied with the original intensity values and the values are summed up. Simple convolution. Everything is multiplied. Say for example, if it is a 5 cross 5 pixels, these 25 values are going to be overlapped with the 25 values of the input image and the corresponding positions are multiplied. And when they are added or summed up, you are going to get a single number. In the previous slide, I told when you move to different positions, you are going to get different images. But practically speaking, they cannot be an image, but as per the mathematical formula, they are going to be a single number. That's why often the theoretical information and the practical information may need some adjustments. Now, how can I get an image? Now, one position, I am going to get a single number. In the same way, when I move my torchlight to another position, or when I overlap my same filter on a different position of an image, I will get another number. So continuously when I move, maybe you can have an overlap or without overlap, it is up to you. You can continuously move and you can get different numbers. When the numbers are put together in the form of rows and columns, you are going to get an image. This is called a sub-image or the first small piece of the original image. Now, how am I going to get different sub-images? For that, change the filter size. Take another torchlight. Again, repeat the same process. You will get another sub-image. When this process continues, you will get different number of sub-images where The region of interest data may be available in more than one position. This is the way how convolution operation is being carried out. This is just an illustration where the red color second row, red color shows the filter and not row, the column. The second column, red color shows the filters, and the first column, blue, shows the original image. Now you can see an overlap between the filter and a portion of an image. When you multiply and add, you can see the green color output, which is again highlighted on a number -4, which is for this specific example. In the same way, when you move on different positions, you will get 9 different outputs as per this example, which is given in a row and column fashion in the last green color. The same way, when you go for a different filter, again the process will change, the values will change. When the values of the filter changes, the original image value will remain constant and the output also will change. So when you keep on changing the values and the dimension of the filter, the probability of getting different sub images with different sizes and contents will. Now, this is a practical example of how the convolution layer will give you the output. You can see a car image, and on my right hand side, you can see around 6 to 10 small rectangles, a gray level rectangles. If you closely observe, they correspond to the front portion of the car. In other words, you can very lightly see what happens or what is there in the input image, which you can call it as a feature extractor or a feature descriptor. Say, for example, I will ask you a question. What will be the object which I am talking about? I am showing you the filter. I am showing you the output. But what will be the original image? It is very hard to find. In this example, I am talking about the back portion of the mouse. Why am I unable to recognize even though I have the feature as per the convolution layers? Because the number of features you have is less. One convolution layer is not sufficient to recognize the object, which we call it as low level features. So how can you solve this problem? Go for multiple layers. That's why we call this method as a deep neural network, where the number of layers are extremely high. When you go beyond one layer, second layer, and third layer, the probability of getting a better feature for your specific input image will increase. And finally, when you go for the end of your convolution layer, you will get the perfect. Thank you.